we want to find the limit as x approaches infinity of 2x minus 3 over 2x plus 5 raised to the x power. Right? So the first thing, as you can see, if you try to plug in the infinity here, you will get indeterminate form first of all, infinity over infinity, and also to the power of infinity, right? That's indeterminate. So what you should do, you should have a substitution. You should have y is equal to 2x minus 3 over 2x plus 5 raised to the x power. Precisely because you want to use the ln. ln of y is equal to ln of this. Right? And we know that when you take the ln of something to the power comes down, and this is what you get. Okay? So now we want to find the limit as x approaches infinity of ln y. So we're essentially looking for this. Okay, so as you can see, we're still unlucky because we have indeterminate forms. So we might as well rewrite this as ln of 2x minus 3 over 2x plus 5 and divided over by 1 over x. Right? Because this way x would be on top here if you would have it without the fraction. But if you try to evaluate it, you still have trouble, right? Because infinity over infinity here, if you plug in the infinity into the x, you will get indeterminate form, infinity over infinity. Right? So you have to use the Hospitals. Well, I will have to write it on a new line because it's going to be a long expression. So Hospital's rule says that you will find the limit the same way, but you will also have derivatives of the numerator and derivative of the denominator. And don't confuse it with the quotient rule. Be careful. It's individual derivatives of numerator and denominator. So the derivative of this is going to be 1 over the input. So 1 over this fraction means 2x plus 5 goes on the top, 2x minus 3 goes on the bottom. That should be clear. Multiplied by the derivative of the inside, which is going to be 2 times 2x plus 5 minus this kept intact and derivative of this, which is 2. Right? Over 2x plus 5 squared, and 2x plus 5, correct that a little bit, 2x plus 5 squared. Alright, and this whole thing divides by the derivative of the denominator, which is negative 1 over x squared. Okay, so what happens? And remember, we're taking the limit of all of this. We need to simplify this. As you can see, 2x plus 5 factors are 2 here and there's 1 there, so we cross it out. So what are we going to wind up with? Let's see, 4x minus 4x, that's gone. 10 plus 6, 16. But there's a negative sign, right, in the bottom, so negative 16. And then x squared goes on the top, so let's put it on the top, negative 16x squared. And by the way, why didn't we try to evaluate the infinity again? Because we would get infinity minus infinity. That's another indeterminate form. Infinity minus infinity is indeterminate. And so we needed to simplify. So negative 16x squared over what? Over this multiplied by this, right? Which is going to be what? 4x squared plus 10x minus 6x, so plus 4x, minus 3 times 5, minus 15. Okay, so as you can see, this picture looks way better now. So, and again, if you try to plug in the infinity, you will get infinity over infinity, and that's indeterminate. So what we're going to do, we're going to have negative 16x squared. We're going to divide it by the highest power of x for each numerator and denominator. Plus 4x minus 15 over x squared, right? You will see how this will work. So you will get negative 16 on the top, and on the bottom you will get 4 plus 4 over x minus 15 over x squared. Now guess what? You can plug in the infinity and you will not get an indeterminate form, right? You will get this. Well, we don't have to have the limit sign anymore. You will get negative 16 over 4 plus 4 over infinity, right? Because we're inputting that, minus 15. Infinity squared is infinity, right? You will get minus 16 over 4 plus, so non-zero number divided by the infinity is 0, right? Non-zero numbers being on the top, minus 0. So you get negative 16 over 4, which is negative 4. But be careful, you're not done. Negative 4 is equal to the limit as x approaches infinity of ln y. Be careful, but you need to find the limit of y itself, right? Because y represented this whole thing, right? So in order to get y, you can put an e as a base and ln y as a power, right? So you would have limit as x approaches infinity of e to the ln of y, right? Because that will make sure that well, let me actually write it down so that you know what I'm doing. So the limit as x approaches infinity of y, this is what we need, right? Is limit as x approaches infinity of e to the ln of y, right? So that should be clear. Now here's the deal. There is a famous theorem that says when you have a composite function, right? Composite meaning one function is the input of the other, right? One function is ln, the other one is e, right? Two different functions. And it's a composite function overall, right? So when you have a composite, you're trying to find the limit of that composite, you take the furthest, the outside function out, and the limit as x approaches infinity applies to the inner function, right? So that should be clear. And guess what? You already found the limit of ln to the y, which is negative 4, right? So you just replace it, and there you go. This is your answer. Thank you so much for watching. See you in the next video.